this problem, we're given the function v of m, which represents the output of my function, and it's the value of an investment in thousands of dollars, and m is the number of months after the investment was made. We are to identify the vertical and horizontal intercepts and the slope and interpret their meanings. So I'm going to start with part A and B, where we find the vertical and horizontal intercepts. What's true with any function, not just linear functions, is that if you are on the vertical axis, if you're a vertical intercept, then your x coordinate, or in this case your m coordinate, would be 0. So here's my input m, here's my output v of m, and I know if I am on the vertical axis, if you were to label any point on the vertical axis, you would notice that its input would be 0. So to find the vertical intercept, part A, I'm going to simply plug 0 in for m, and I'm going to get v of 0 equals 118.4 minus 2.31 times 0, and since 0 times any number is 0, this becomes 0, and I get that v of 0 is 118.4. So written in point notation, since I'd like to actually get a rough sketch of a graph here, in point notation, that means that my input was 0 and my output was 118.4. So for me, this is m, my input, right? Whatever variable is in the parentheses is your input variable, so we replaced m with 0. And my output is v of m. More importantly, to interpret what's going on is to look at the units. M was in months after the investment was made, and v of m is the value of the object in thousands of dollars. So this means 0 months after the investment, meaning when I made the investment, the value of the investment was 118.4, but be careful, $1,000. So when the investment was made, it was worth 118.4. That's $1,000, which is kind of a strange way to write it. Maybe I would write it as $118,400 rather than writing $118.4 thousand. So that's your initial investment. So if you plotted that on the graph, that would be the point right here, 0, about 118. So somewhere around there, you'd have a point. That would be your starting value, if you will. At time 0, you're at $118.4 thousand. So remember, this is in thousands and this is in months. Don't quite have enough room to squeeze in the fact that this is in thousands of dollars. So the idea is that because this is linear and we have a negative slope here, what's going to happen is the value of investment is going to go down for some reason. And when we get to part C, we'll interpret what that slope means. But certainly, if you have a negative slope, the graph is going to go down, and eventually we're going to hit some horizontal intercept. And at this point, I have no idea whether it's going to be 20, 30, 40, what have you. So we're going to have to go back and find that. So part B is going to work a lot like part A did, except in part B, they're asking for the horizontal intercept, which means where does the graph cross the horizontal axis? So we know it starts here, it's going to go down, and it's going to hit the horizontal axis somewhere down here. If you're on the horizontal axis, your output is 0. So a technique to find the horizontal intercept for any function, not just linear, is to replace the output variable, this guy, with 0. So if I literally did that, don't know what we're going to get for an input yet, but I'm going to put 0 in as a output. That's this. So v of m would be 0, and I would copy the rest of the equation then. Because this is being subtracted here, this term, I'm going to add it over. I'm going to add 2.31m to the right-hand side, and I'm going to add 2.31 to the left-hand side. So 0 plus 2.31m is 2.31m. Subtracting something and adding that same thing sums to 0, so I would have the 118.4. Now, don't forget that the 2.31 is being multiplied by m. What I need to do is divide it to isolate the variable m. So if I divide by 2.31, remember that this is in months, you actually can have a partial month. It's 118.4, and then we are to divide that by 2.31. So my m is approximately 51.3, and if you remember right what that means, since it's m is the number of months after the investment. So this is 53.1 months. So in math, without the words, you would just say this is the horizontal intercept, 51.3 comma 0. That would be somewhere, this would be about 50 right here. So 51.3 would be somewhere in here. The important thing is that we've determined the horizontal intercept. The harder part is to interpret the practical meaning. We've written it as an ordered pair. So the meaning would be that the input is the amount of time in months that it takes for the output, which is the value, to become $0,000. So don't forget that this is in months. And the output was V of M, which was in thousands of dollars. So you take that point, and you would say after 51.3 months, the investment is worth nothing. And at this point, because it actually is zero, you could write $0,000, but let's face it, $0,000 is the same thing as $0. So your investment is worthless after about 51 months, if you want to be picky, somewhere around 51.3. So those are the first two parts. Identifying the slope is going to look a lot different because the slope is not just an ordered pair. It's not just an input and a output. The next question, C, says find the slope. So in general, slope can be thought of as change in y over change in x. But in many cases in math, we don't use x and y. In fact, in my problem, we didn't use x. For an input variable, we used m, for example. So a more general way to write slope would be to say that it's always the change in your outputs, sometimes called y, divided by any change in your input, sometimes called x. So for my problem, the way that's going to look is that my slope is going to be change in the value, v of m, and my input is m, right? The variable in the parentheses here is m, indicating that my input variable is m. So my slope would be how fast the value is changing over how fast time is changing. And I like to put the units in there. My units on my slope are going to be as follows. Since v of m is in thousands of dollars, that would be in the numerator of my slope. And in my denominator, since m is in months, my denominator is going to be in months. By the way, when we divide in math, it's oftentimes read per. So when we get the slope, it's going to be thousands of dollars per month. And if you remember what slope is, it's always telling you how fast something is changing. And since this is linear, I'm assuming that it is constant change. So the value of the investment is changing at a rate of so many $1,000s per month. I can already tell you that it's negative, so it's going down so many $1,000s per month. This actual slope will tell me how much. So the easy part of the problem is just to identify the slope. The slope is, simply put, negative 2.31. It's the coefficient on the input variable. Now, if you put the story to it and put the units in here, this is in thousands of dollars per, I write the division symbol, per month. And since slope is a fraction, it may be helpful to think of this as a fraction, but as to not change the value of the slope, you would put a 1 down here. So this means if you change m by 1 month, if you wait 1 month, then the change in the value of your investment will go down, because negative change means decreasing. Your value of the investment would go down about $2,000 if you want $2.31 thousand. So we could say as a sentence, the value of the investment is decreasing at a constant rate of negative, and I'm going to write 2.31 thousand as $2,310 if you just let me move that decimal to the right 3 times. I tell my students to write out the number in question like this is in thousands. Count the number of zeros, there are 3, and that's how many times you would move the decimal to the right. So to convert this into thousands, you move the decimal to the right 3 times, in which case you would get negative $2,310, and remember that is per 1 month, so you could just say per month. By the way, we call that a unit rate whenever we have a 1 in the denominator of the slope. This is what's happening every 1 unit in time, 1 month. So the value of the investment is decreasing at a constant rate of $2,310 per month. It just means you're starting here at about 118, and every time you step to the right 1 month, so that's changing input over here, the output will go down 2.31, and remember that's in thousands of dollars.